Hi everyone, welcome back to another Hackerrank series. Today we're going to see a very popular question. In fact, it has almost become like a meme in the interview questions thing, which is how to reverse a linked list. This is a question that, in my opinion, on when you hear it for the first time, or when someone tries to ask you this question, they try to make a big deal out of it and they make it very intimidating when it really doesn't have to be. It's just that you need to have a clear mind and you just need to trace the movements of the linked list slowly and carefully. So, how do we do it? This question, we don't really benefit much from the preamble. I'll just explain to you in verbally like how it looks like. So a linked list is something that has a header node and it has tails like this. 3, and the last one will have a none or a null. So other than the last one, not almost, other than the last one, every other node has a tail. That means this is the header node and it has a tail, which is another header node that has a tail, which is another header node, just that it doesn't have a tail and it concludes at a none. So how do I know this? I can look at the source code, so to speak, of how the singly linked list feature is programmed for us. So yeah, they create a new instance of this. And if we were to even print it out, like let's just print out the list. You would see that it's an object. So at the end of the day, they want to see an object over here, like an object class, like a class object over here, a singly linked object over here. They don't want us to just do the sorted reverse true or something over here. So in order to achieve that, we need to make use of the class methods to twist the singly linked list from this way to the other way. So how do we do it? Which is what I feel like we would benefit a lot by discussing today. So before we jump into the code, I just want to like show you how it will look like. Like how a linked list will look like as an end result. So we have 2 and we have 3. 3 points here, 2 points here, and 1 should point to none. This is the final end goal that we are striving to get towards. So how do we do this? So to do this, first thing, if I were to, like for any linked list, we know that we have a header and we have a tail. The rest of it is all tail and we only have a head. So it makes sense to start with the head. So the header, I need to assign it to another value, which is none. That'll be the first, that'll be one of the easiest, obvious thing to do, right? To make sure the headers next is not this, and instead it is none. But if that is the first operation that I do, I'm literally saying that I'm going to forget all of this, which is a no-go. So to prevent that from happening, what I can do is before I assign the next of the header to be none, I can store this somewhere. So I store the whole thing in this thing called temp. So after I store it in temp, I can assign this to whatever the next value is going to be. So as you can see, there's going to be a repeated operations. I'm going to assign this to next. I'm going to remember the next one, and then I'm going to assign this to the previous one. Next one and previous one, next one and previous one, next one and previous one. It's going to go in this loop, and the previous is going to start with a none. So for better visualization, I'm going to use a different method of showing it. I'm going to store this in, I'm going to create 2 variables. The first variable is next. Okay, let's make it simpler. Not simpler, next. And this will start with none. And a temporary storage, TMP. And this will be 2, 3, none. So 2, 3, none. So the first thing that I'm doing is I'm storing it into the temp while I assign the header to next, which is none. So this part is done. And next step, I need to make sure that the next value is now referring to this. Like I need to make sure this is the next value. So the next value would be 1 and n because it's already linked to the n. So I remember 1 and n. And now if these two are already processed, now we treat this as the header. We have done one complete circle. So this is the header now. And header, we first store whatever's at the tail. So this is the tail. So tail is 3n. And it's going to store itself to the next, which is 1n. And the next value is now going to be 2, 1n. And we can go to the next item, which is 3 is the header now. 3, I'm going to store the previous one, which is none. And I'm going to assign the next of this header to be this next, which is 2, 1n. And I will assign next to be 3, 2, 1n, which is all of it. And since my temporary is now n, and I'll set the header to be none. Since the header is none, we can just use that as a failing condition, and we will just terminate the program, and we are good to go. The orange is the correct answer. So this is the pseudocode explanation of how I want to do this. So let me just code it out now. If you guys need to do so, please rewatch the video in different parts, slow it down, or maybe wait for me to just write out the code so that you can follow what I'm doing it, like how I'm doing it. So as I mentioned just now, first things first, I need to assign a variable to none. So next is equal to none. Whoops. And subsequently, I can kickstart the loop. The loop has a failing condition, which is when the header becomes, let's, instead of list, I'm going to call this header. While header exists, what I'm going to do is I'm going to first put it in the storage, the temporary storage. So tmp is equal to head dot next. So temporary is 231, which is this. The next thing I need to do is the headers next needs to be assigned to this. So head dot next is equal to nxt. And I need to make sure the next value, which is 1 and n. So it is next is going to be head. Like this is head, right? So head is going to be, so the next is going to be the header. Because the header, once I transform the next value to, I assign the next to be this, I sever the connection over here. The blue connection is severed. So now it's just an entity without this whole thing. It'll just be these two things. Head now represents these two things. This whole chain is being represented by temp. So next is equal to head, and head is equal to temp. Whatever the previous head was, it'll now be temp, which is this thing, this long line of things. And I'll keep doing this process until I hit none. As you can see, next is the one that we are looking for. Like at the end of the day, after we finish all of this, next will have the most updated value, which is 321n, which is what we want. So I can just return next, and this should be our answer. Yep. So once again, you guys can maybe like just take it slowly, process this step by step at each stage, go through the code, like what it means. And if you understand this, you should be a pretty, like, I would give this question a medium rating for those who are like unsuspecting, those who have no idea how to do reverse a linked list. This would be a really challenging question for them. But with more practice, as you see more of these type of questions, we need to find out where's the failing condition, which in this case is when we hit the none. And if we can just do a series of manipulations using the class methods itself, we are able to reverse a linked list. And that is the infamous reversing linked list question, and hope you guys enjoyed it and learned something out of it. Oh wait, I haven't submitted. Okay, let's hope it passes all the test cases. That's taking a bit long. Okay, wonderful. So it passes all the test cases, and yeah, leave a comment if you feel like I could have explained something better, or if you think my explanation is absolute garbage, please let me know as well. It's not very easy to explain, so it's also good practice for me to improve my explaining skills. But yeah, this is the reversing linked list solution, and I'll see you guys in the next video. Thank you. Bye.